Welcome to the channel. Today, we are going to explore one of the most important topics in all of mathematics, the foundations of mathematics. Now, before we can solve equations, work with algebra, or understand geometry, we need to understand something deeper: what mathematics is built on. Just like a house needs a strong foundation to stand, mathematics also depends on a set of basic ideas that everything else is built upon. These include definitions, axioms, postulates, rules, theorems. And by the end of this video, you will clearly understand how all of these work together to form the powerful system we call mathematics. So let's begin. Section 1. What are foundations? Mathematics is not just numbers and formulas. It is a logical system. Everything in mathematics follows a structure, step by step. From simple ideas to complex conclusions. Think of it like building a pyramid. Basic ideas, logical steps, complex results. If the bottom is weak, everything collapses. That's why understanding the foundations is so important. Section 2. Definitions. Let's start with the first building block: definitions. A definition tells us the exact meaning of a mathematical term. Without definitions, mathematics would be confusing and unclear. For example, a point is an exact location in space. A line is a straight path that extends forever in both directions. A triangle is a shape with 3 sides. Now, notice something interesting. Some definitions use other words that also need definitions. So mathematics builds a system where everything is clearly explained. Important idea: definitions do not need to be proven. They are simply agreed upon meanings. Section 3. Axioms. Next, we move to axioms. Axioms are statements that are accepted as true without proof. You might wonder, why don't we prove them? Because if we tried to prove everything, we would never start. So we accept some basic truths to build upon. Examples of axioms: things equal to the same thing are equal to each other. If equals are added to equals, the results are equal. These ideas seem obvious, right? That's the point. Axioms are self-evident truths. They form the starting point of reasoning in mathematics. Section 4. Postulates. Now let's talk about postulates. Postulates are very similar to axioms, but they are usually used in geometry. For example, Through any 2 points, there is exactly one straight line. A straight line can be extended infinitely. These are assumptions we accept without proof, just like axioms. Key difference. Axioms, general mathematics. Postulates specific to geometry. Both are foundational truths. Section 5. Rules. Now, let's move to something more active. Rules. Rules tell us how to work with numbers and expressions. They guide our calculations. Examples include order of operations, BODMAS/PEMDAS. Rules of addition and multiplication. Algebraic rules. For example, when solving 2 plus 3 times 4, we don't just calculate from left to right. We follow a rule of BODMAS. Here we have 2 operations, addition and multiplication. So we multiply first, then add. So the answer becomes 2 plus 12 is equal to 14. Without rules, everyone would get different answers, and math would not be reliable. In this case, if we add first, let's see the results. 2 plus 3 is equal to 5. 5 times 4 is equal to 20. So do you see the difference? Now I hope you understand how rules are important in mathematics. Section 6. Theorems. Now we reach one of the most powerful parts of mathematics. Theorems. A theorem is a statement that has been proven to be true. Using definitions, axioms, postulates, rules, we build logical steps and arrive at a conclusion. Example: the angles in a triangle add up to 180 degrees. This is not just an assumption, it has been proven. Another example: the Pythagorean theorem. In a right triangle, the square of the longest side equals the sum of the squares of the other 2 sides. This is a powerful result, and it comes from logical reasoning. In the next videos, I'm going to proof these theorems and more others. Important idea: theorems are the results of mathematics. Section 7. How everything connects. Let's quickly see how everything connects. Definitions explain terms. Axioms or postulates, basic truths. Rules guide operations. Theorems, proven results. It's like a chain. Basic ideas, logical steps, powerful conclusions. That is the beauty of mathematics. Mathematics is not just about solving problems. It is about thinking clearly and logically. When you understand the foundations, everything becomes easier. Algebra makes more sense. Geometry becomes clearer. Problem solving becomes faster. So next time you study mathematics, remember, you are not just memorizing formulas. You are building knowledge on a strong foundation. If you found this helpful, like the video, subscribe for more mathematics lessons. and share it with someone learning mathematics. See you in the next video. Thank you for watching.